Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. So, in the previous video, we have discussed briefly about the ionic bond. In today's video, we are going to briefly discuss about the covalent bond. Okay. So, what are covalent bond? As we have seen in ionic or electrovalent bond, what happens? Electron transfer takes place. One of the atoms, that is metallic atom, gives up electron, and one of the other atom, that is the non-metallic atom, takes up the electron to form a ionic bond. Why an ionic bond? Because first of all, ions are formed and then only the molecule is formed. So as the molecules are formed by the attractive force between the two oppositely charged ions, hence it is known as ionic bond or electrovalent bond. Now what is covalent bond? Here electron sharing takes place. Okay, electron sharing takes place. Now let us consider one example. If we consider the formation of water molecule, okay, so if you see the formation of water molecule, what happens? There is an oxygen atom. Say oxygen atom has 6 electrons in its outermost shell. So 6 electrons in the outermost shell. So if this is an oxygen atom, it has 6 electrons in the outermost shell. Okay, so let us just mark those electrons as cross. 1, 2, then 3, then 4, then 5, then 6. 6 electrons in the outermost shell. Okay, now a hydrogen atom has only 1 electron in its outermost shell. So this hydrogen atom has 1 electron in the outermost shell. This electron, what happens? This hydrogen atom shares its electron with one of the electrons with one of the electrons of the oxygen atom. So basically this forms a pair which is being shared between both the atoms, both the hydrogen and the oxygen atom. It is being shared between both the oxygen and hydrogen atom. Okay. On the other hand, if we consider another hydrogen atom, here is another hydrogen atom. Why another hydrogen atom is required? Because see, when the oxygen atom shares its one electron with the other electron of the hydrogen atom, at that time you can say that the oxygen will have a total of 1, 2, 3, 4, 5, 6 and then 7 electrons. So it still does not satisfy the criteria for stability, that is oxygen need to have the electronic configuration of its nearest noble gas, that is neon, and neon has 8 electrons in the outermost shell. So it should have to share its another electron with the other electron of another hydrogen atom. Okay, like this. Okay, fine. So in this way the electrons are being shared between the oxygen atom and the hydrogen atoms. Okay, so I can just read out this figure like this. So here is the oxygen atom in between. Okay, and just if I draw its shell a bit like this, okay, it will be easier to demonstrate the formation. And here is the hydrogen atom. Okay, hydrogen atom. So there is a portion where the atoms overlap their structures. Okay, like this, it overlaps the structures. Okay, so now oxygen, now see, oxygen has 6 electrons, 1, 2, 3, 4. These have not taken part in any bond formation, whereas the hydrogen atom shares its electron. So this is 1 electron and this is 1 electron of oxygen, this is 1 electron of hydrogen, this is 1 electron of oxygen. So hydrogen does not have any other choice but to share its one of the electrons with the one of the electrons of the oxygen atom. So in this way what happens? A sharing takes place, isn't it? A sharing takes place and the oxygen atom forms bond by sharing one pair of electron with each of the hydrogen atom. Remember, it shares one pair of electron with each of the hydrogen atom. In this way a bond is formed, and these two electrons, the electrons in the shaded part, okay, this is the common region between the two atoms where the shared pair of electrons lie. Okay, so the electrons are not totally given away or not totally taken up by any particular one atom, rather the electrons are being shared between the two atoms. This kind of bond, as it is happening by the mutual sharing of electrons, is called the covalent bond. Okay, so and it is clear that what is covalent bond? It is mutual sharing of electrons that results in the formation of covalent bond. Okay, fine. Now, so for the formation of covalent bond, remember one thing, that for the formation of covalent bond, both the atoms, okay, here they are the atoms that not only both the atoms that are involved, all these atoms have to be non-metallic in nature. Okay, so for covalent bond, remember this thing, for covalent bond formation, okay, for bond formation, fine, for bond formation, or the atoms must be non-metallic. The atoms must be non-metallic. Okay, the atoms must be non-metallic in nature. Only then covalent bond is formed. Because see, if all the atoms are non-metallic, all the atoms, they definitely will not give up electrons. All the atoms will try to retain their electrons in their shell. So when no atom is willing to give up its electron, then only the concept of sharing, or then only the chance of sharing the electrons comes into formation or comes into act. Okay, so for the formation of electrovalent or ionic bond, as you have noticed in the previous video, if you have not watched the video, please do watch that video. We have seen that one atom has to be metallic as it gives away the electron, and another atom has to be non-metallic as it takes up that electron which is being released by the metallic atom. Okay, in this way what happens, bond formation takes place and the atoms share their electrons and bond is formed. Okay, so this is covalent bond. Okay, I think it is clear. Now see, covalent bond can also be formed between the atoms of two similar kinds that forms a molecule of a element. Here these are the molecules of compounds. Remember this thing, these are the molecules of compounds. Fine. Now when you are considering the molecules of elements, now see, another thing that you have to notice here is that the number of electrons shared between this hydrogen atom and oxygen atom is two, that is only one pair, whereas on the other hand the number of electrons shared between this oxygen atom and this hydrogen atom is also 2, that is one pair. So when you are considering two individual atoms, okay, only one shared pair of electron appears to be in the common space, here also, here also. So this kind of bond is called the single covalent bond. Okay, what is called single covalent bond, as you can see in this case. So covalent bond can be of three types: single covalent bond, double covalent bond and triple covalent bond. Three types of covalent bonds are there: single, double and triple. Okay, so let us take just another three example. Okay, so I am just showing the formation of single covalent bond with the help of, say, chlorine molecule. Okay, chlorine atom has 7 electrons in its outermost shell. So it's 1, 2, 3, 4, 5, 6 and then here 7. So another chlorine atom comes here. This chlorine atom has also 7 electrons in outermost shell. 1, 2, 3, 4, 5, 6, 7. Okay. Now what happens? This chlorine atom also needs 1 electron. This chlorine atom also needs 1 electron. What they do, they end up sharing one pair of electrons in between themselves. And thus what happens, when these chlorine atoms overlap, the atomic space overlaps. See, something like this happens. The atomic space overlaps, okay, and the shared pair of electrons remains in here, okay, and the other electrons are free. 1, 2, 3, 4, 5, 6. Okay, and here 1, 2, 3, 4 and then 5, 6. So now if you consider both the atoms, this chlorine atom has, see how many electrons? 1, 2, 3, 4, 5, 6, 7 and 8. Okay, also this chlorine atom has 1, 2, 3, 4, 5, 6, 7 and 8. So 8 electrons, both the chlorine atom has now 8 electrons, but they have not individually given up electron or accepted electron from any other. They have just shared the electrons. By sharing one pair of electron, they form a single covalent bond. Okay, now what about double covalent bond? Okay, so double covalent bond. Now double covalent bond is something like this. If you consider oxygen atom, the formation of oxygen molecule, this is a chlorine molecule, Cl2. Now if you consider the oxygen molecule, what happens? See, oxygen atom has 6 electrons in outermost shell. Okay, take another oxygen atom. It has also 6 electrons in outermost shell. So 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Okay, 6 electrons in outermost shell. Here what happens? Both the oxygen atom needs to share. If they share only one pair of electron, will they have 8 electrons in the outermost shell? No. See, count it: 1, 2, 3, 4, 5, 6, and then 7. Here also 1, 2, 3, 4, 5, 6, and then 7. So they need to share another pair of electron. Only then they will have 8 electrons. Remember this thing: they are not giving away the electrons totally or total, but they are just basically sharing the electrons. And in this way, now both the oxygen atom will have